In hands-on number 3, we'll look into more of the dynamic action functions, and we will focus on dynamic array data generation, which can be quite a complex task. And the motivation can be like this. The real service is unable to provide a realistic amount of test data. Say you develop a web application and you need to ready for displaying 50 assets, not just 3 to 8 assets that we have in the sample data. So how to mitigate this issue? In this hands-on, let's create additional rules that will append some randomly generated asset values that will follow the sample data assets that we imported in the past. In the first step, we'll make the simulation generate 50 assets. All the assets in the response should have the market quote time set to about 10 minutes in the past. The time zone should be UTC. To implement the first step, we'll have to create 2 separate rules, and we'll learn 2 special dynamic action functions. First of them, to set the intended number of items to be generated in an array, and the second special dynamic action function that will be applied to all individual array items, and that will do the same action for all of them. In this case, we'll be setting the market quote time to some quite recent value, because we don't want to keep the historical value from the imported data. So let's do it. In the SE Designer, we'll create a new rule called set asset count to 50. In this rule, we'll create a new row, we'll display it in row detail, and since we again want this request response row to always match, we'll ignore everything in request and we'll just focus on response. Here we need to set the type to portfolio suggestion, but the only other thing we'll do here will be setting the intended number of items in an array to be generated, and we intend to generate some 50 assets. If we have a closer look, you can see there is also quite a similar function that will make it possible for you to copy array item count from some other array, perhaps from request. That's quite handy if in your request there is an array with, say, 5 items and you need to generate some results in a response for each of these items. So you will just copy the intended number from request to response. On response, you also expect 5 items if you receive 5 on request. So this is the purpose of copy array item count function. But in our case, it will be a bit simpler. We'll set the intended number of items to be generated to 50. So let's test it. I'll restart simulation and press send. If you scroll down, these are the assets we intended to generate. Just their content is empty, since we didn't specify any rules to generate the individual fields for these new assets. So this is what we'll do now. For start, let's generate just the market quote time field for all the array items. So let's create this set market quote time rule. And inside it, we'll again add a simple row. Inside that row, we'll ignore everything on request so that this request response row always matches. And on the response side, we'll use a special dynamic action function for arrays that will help us apply the same changes for every individual asset item. And this special action function is called array template function. Okay, now we need to specify what should be the change to be applied to each individual array item. For that purpose, I'll create one array item inside this array by clicking Add, and currently, as you can see, by default all these fields are set to not present. So they would be not present. This is not what I want, so I'll ignore everything and I'll just touch this market quote time. This market quote time should be 10 minutes in the past. For that purpose, I'll use this set relative date time function. you can see again there is a similar function that will help you do the same but relative to some other field. Say that you have some timestamp in request and you want to generate another timestamp for your response 10 minutes in the future, you can use this function. But in our case, again, it will be simpler. We just need to generate timestamp relative to now. And in this case, now is always UTC. This will generate the UTC timestamp. So let me select this action function that will be applied to each individual array item. And we also need to specify arguments. So again, I use the svhelp to find out what the format of these arguments is. A value 10 minutes in the past will look like this. It's minus 0 hours, 10 minutes, 0 seconds. And now, separated by hash, we can optionally specify the format of that time. So let's start with year, month, day, hours, minutes, and seconds. And since the value here didn't get read, it means SV is okay with this format. So we can press save and close, and we can restart simulation and test the value. Here, when I press send, you can see the time changed. It's now 10 minutes in the past because currently it's 1840 UTC. So you can see the value was applied for the samples that we imported in the past, as well as for the newly generated array items. In the second step of this hands-on, we'll generate the rest of the fields of the newly generated items with some random values. The ISIN field will look like this, ending with 4 randomly generated digits. This will be the asset name. The type should always be set to equity. This will be the units, and price in USD like a money value with 2 decimal places. The risk score column should be populated by copying the value from the request risk level element. And we need to make sure that we keep the originally imported data intact. So the first several items should stay the same, because whenever you import some data or record some data, that's valuable input. That's as realistic as it can get, so we'll keep it there. By the way, from the same reason, it's the best practice to never change data recorded from the real service in the learned data row. We should keep the recorded data as they are, as a sort of an evidence of what was once reality. For hands-on number 3, we'll likely need 3 rules. I think we already have this one and this one, so let's create the last one. So here I'll create a new rule. Inside that rule, we'll create a row. Let's display it in row detail. So let's select the type as suggest portfolio structure here, because later we'll want to copy this risk level element into the asset risk score field. And let's perhaps keep the type is condition this time, since only if type is suggest portfolio structure, this risk level value will be available, and only then it can be copied to asset risk level fields. On the response side, we'll set the type to portfolio suggestion, and we'll again use the array template function, add the template item, initially ignore everything, and now for ISIN, let's use the random number generator, and in the svhelp I found the arguments should look like this. You need to specify the lowest and the highest possible generated number. So since we are generating last 4 digits of that ISIN, it should look like this. And now we'll specify the format. So this should be the prefix followed by 4 digits with leading zeros. The name should also be randomly generated, and it should look like this. The type should be constant. We should always set it to equity. For units, let's generate a random number with 4 digits. Just 2 of them will be before the decimal dot and 2 of them after the decimal dot. Yeah, and we can also generate it partially without leading zeros. which we'll accomplish with this lowercase d. So this kind of format means that if the randomly generated number is 0, it will be generated as 0.00. So there will be just one leading 0 before the decimal dot, which is also the format used to generate money values, like the price in USD. Here, the required number of digits was 5, so there will be one more potential digit before the decimal dot. For the risk score field, we'll simply copy it from request, and we will ignore the market quote time. We will not touch its value here. And that's because we already generated in a different rule. I'll press save and close, and let's restart simulation and test it. When I click send, we can see the ISIN is now randomly generated, as well as the asset name, units, and price in USD. When I press send again, the numbers are different. When I press send again the numbers are different. So indeed, we generate the values randomly. Just one additional thing that I don't like here. As you can see, we start with asset items that are randomly generated. And in the instructions, the requirement was to keep the originally imported sample data intact. So why is that? When we go to the data model and collapse this rule, you can see this rule has higher priority than the samples from documentation. So whatever the samples from documentation sets can be overwritten by this rule with higher priority. So let's move this rule below samples from documentation, and now this rule number 6 will provide us the randomly generated baseline, but this rule, samples from documentation, will override part of the fields for part of the items by whatever we imported here in the past. Let's restart simulation, test it again, and you can see we have the imported data back, and at the end there is a lot of randomly generated items. And since we completed all the steps required in this exercise, we can go to the dashboard and check the result. And it's okay. But before the end of this video, let me show you 3 remaining array functions that we haven't covered yet. When I display, for example, this row from samples from documentation rule in row detail, like this, you will see that when importing, this replace array function is used. Replace array is like set for arrays, in that sense that for a couple of items in your array, the replace array function sets the values individually. So it's like having set function for simple fields, except that in an array you can have a different intended number of items to be generated. So in our case we have 50 items, and this replace array function just sets values for the first 4 of them. We also haven't mentioned condition functions for row matching. We have 2 of these, compare ordered and compare unordered. And in this case, they are comparable to the is function. Just in arrays, it makes sense to distinguish between comparing the items in the ordered fashion, which is much faster. It's exactly like the is function, comparing the first item of one array to first item of the other array, second against second, and so on. And this compare unordered function is used when you need to match arrays irrespective of order. For example, if in a request you have a shopping cart and inside that shopping cart you have a couple of items, the order doesn't matter here. So if you want to match such an array on request against some values here in the data model, you should use compare unordered function. Just keep in mind that such an unordered way of comparison will perform much slower. So for large requests, comparing in the unordered fashion can slow down your simulation. And that's it for arrays.